Dragon is in countdown. Falcon 9 is in startup. Dragon, SpaceX, go for launch.
You are looking live at Launch Complex 39A at Kennedy Space Center. We are about 20 minutes away from liftoff of this Falcon 9 rocket for the 26 Commercial Resupply Services mission from both NASA and SpaceX to the International Space Station. Good afternoon and welcome to live coverage of CRS-26. I'm Jasmine Hopkins with NASA Communications. Fueling of the Falcon 9 began about 20 minutes ago, and we are counting down to an instantaneous launch at 2:20 p.m. Eastern Time. Tuesday's launch attempt was scrubbed due to weather, but fortunately, it's looking much sunnier on the Space Coast today. This mission will deliver more than 7,700 pounds of food, supplies, and science to the space station. This includes a new pair of roll-out solar arrays to power the orbiting laboratory, and tomato plant seeds for the continuous fresh food production system. These resupply missions help NASA and our partners continue research that could better our life right here on Earth and help us explore deep space. That being said, let's go now to SpaceX headquarters in Hawthorne, California, where Jesse Anderson is standing by to tell us about the rocket fueling today's mission. Jesse, how are things looking?
Great, thanks Jasmine. Hi everyone, my name is Jesse Anderson. I'm a production engineering manager here at SpaceX. It's great to be covering today's mission in partnership with NASA. The rocket that you're looking at on your screen is brand new. The Falcon 9 and Dragon spacecraft will be flying for the first time on today's mission. So far this year, we've launched 4 Dragon missions, Crew 4, Crew 5, Axiom 1, and CRS-25. Today's launch marks SpaceX's 5th Dragon launch of 2022 and our final Dragon mission this year. Now, looking at the rocket on your screen, above the Falcon 9 is the Dragon spacecraft sitting at the very top. Now, as I mentioned previously, the Dragon that you're seeing on your screen will be embarking on its first flight and will be joining the Crew 5 spacecraft already docked at station. Moving down the vehicle, we have our reusable 2-stage rocket. Falcon 9 is actually 2 rockets in one. The lower part, which is also the largest part of the rocket, is called the first stage. The smaller stage above the first stage and the black inner stage is called the second stage. Not only does SpaceX's second stage look similar to the first stage, it also has the same diameter, uses the same metal in the tanks, same computers, same propellant, and nearly the same engine. This allows us to use similar tooling, design, and systems to essentially build 2 rockets that are more reliable. Now, above the first stage and black inner stage is our second stage. The stages will separate about 2.5 minutes into flight, and then the second stage will ignite its MVAC engine, which is the 10th engine on the rocket, to carry Dragon to its desired orbit. Now, moving down the rocket, the bottom of the first stage has 9 Merlin 1D engines, hence the name Falcon 9. These engines accelerate the vehicle through the Earth's atmosphere and into various orbits in space. And we will be attempting to recover the first stage on our drone ship named Just Read the Instructions today, and there you can see it on your screen, currently positioned off the coast of Florida in the Atlantic Ocean. But for now, let's turn it back over to you, Jasmine.
Thanks so much, Jesse. In addition to SpaceX in California, NASA teams both here in Florida and Texas are monitoring today's launch as well. You'll hear from Sandra Jones inside Mission Control Houston, but first, let's check in with NASA's Megan Cruz, who's monitoring the launch team here at Kennedy. Megan?
Thank you, Jasmine, and welcome everyone into Hangar AE at nearby Cape Canaveral Space Force Station. This is where the Space Force monitors things like the range for us, making sure it's safe to fly where we intend to fly, but also the weather, which, as you said, Jasmine, is looking much better today than it was on Tuesday. When we tried to launch on Tuesday, we were 30% go because of things like rain and clouds. Today, we are 80% go. Launch Weather Officer Alina Moses is currently tracking some storms to the east of us, but expects them to remain well offshore today. Now, right now, fueling of the Falcon 9 rocket is underway. It started about 20 minutes ago at T-minus 35 minutes. RP1, or rocket-grade kerosene, is being loaded into the first stage. Liquid oxygen is also loading into the first stage and should begin on the second stage momentarily. The white clouds you see that are coming off of the rocket, that is because SpaceX is venting off some of that liquid oxygen to maintain the right pressure in the tanks, and those clouds form when the LOX makes contact with the humid Florida air. Now we have an instantaneous launch opportunity at 2:20 and 43 seconds Eastern Time if we want to dock with the International Space Station tomorrow morning. For more on that, let's head over to Sandra Jones in Houston.
Good afternoon. I'm NASA's Sandra Jones here inside the International Space Station Flight Control Room at the Johnson Space Center in Houston, Texas. Mission Control Houston is the nerve center for space station operations, and our flight control team is on console as they are 24 hours a day and are ready to support today's cargo launch. Leading the team in mission control during today's launch and during this Orbit 2 flight shift is NASA Flight Director Adi Bulu. The ultimate destination for today's Cargo Dragon launch is, of course, the International Space Station, where right now the 7-person Expedition 68 crew continues to live and work. That crew includes NASA astronauts Frank Rubio, Nicole Mann, and Josh Cassada, as well as JAXA, or Japan Aerospace Exploration Agency astronaut Koichi Wakata, and 3 Russian cosmonauts, Sergei Prokopyev, Dmitry Petelin, and Anna Kikina. When Dragon arrives to the space station on Sunday, it will dock to the zenith, or space-facing port of the Harmony module, and NASA astronauts Josh Cassada and Nicole Mann will be on tap to monitor the approach and docking. Dragon will spend about 45 days attached to the International Space Station before it undocks and returns to Earth with critical research and return cargo and splashes down off the coast of Florida. But for now, everything continues to look good on the station side for today's launch, so we'll toss it back over to you, Jasmine.
Thank you, Sandra and Megan, for those updates. We are now about 13 minutes and counting from liftoff of CRS-26, so let's get a closer look at some of the science flying on this mission. The VEG-05 experiment on CRS-26 could help feed astronauts as they explore deep space in the future. In this experiment, small tomato plant seeds are grown in 2 veggie chambers with different LED light conditions for 104 days. Then they are analyzed for how many tomatoes they grow and their nutritional composition. Station crew members will rate their flavor, texture, and juiciness. This resupply mission will also increase the power on station with 2 new roll-out solar arrays. These are also called IROSAs. After being installed on upcoming spacewalks, the arrays will roll out using stored kinetic energy, almost like a yoga mat. The IROSA is a new design that uses 1 piece of flexible material that snaps open in space. We are now at T-minus 11 minutes and counting from liftoff of the 26th Commercial Resupply Services mission from both NASA and SpaceX to the International Space Station. So let's bring back Jesse now to tell us more about today's launch and Dragon. Jesse?
Thanks, Jasmine. As we near the end of the year, today's mission marks SpaceX's 192nd overall launch and the 5th flight of Dragon to the International Space Station this year, following the launches of Crew 4, Crew 5, Axiom 1, and CRS-25. To give a bit of history, Dragon has been flying for 12 years. Dragon made its debut at the orbiting lab in 2012 as the first private spacecraft in history to visit the International Space Station. Now, since then, it's made 32 trips to and from the orbiting lab, and today, Dragon is one of the few vehicles that can deliver significant cargo to the space station, and the only vehicle that can deliver cargo from it. Falcon 9 and Dragon were both designed with reflight in mind, and the vehicle hardware is built to support multiple missions with minimal refurbishment. Now, to date, 16 of our missions have flown on flight-proven Dragons. While today's launch marks the first flight for this particular Dragon and Falcon 9, we do plan to recover and fly both the vehicle and spacecraft again in the future. Now, so far, we've reflown first stages 127 times, and that includes Falcon 9 and Falcon Heavy flights, and are planning to recover this one on our drone ship just read the instructions today. Now, if successful, it will mark the 153rd recovery of an orbital-class rocket. Now, we're at T-minus 9 minutes until liftoff, with the range and weather tracking green for an on-time launch. So we'll turn it back over to you, Jasmine.
Thank you, Jesse. There are also several international partners contributing to the science and research on today's mission. Earlier this week, I had the honor of speaking with Carlos Moura, president of the Brazilian Space Agency, about today's launch. Let's take a look at what he had to say. There are several international partners flying as part of the CRS-26 mission. I'm so glad now to be joined by Carlos Moura, president of the Brazilian Space Agency. So glad to have you here.
Thank you, Jasmine. We are open to discuss a lot of good opportunities with NASA and the United States.
Right, and one of those great opportunities is the Sport CubeSat. The Brazilian Space Agency partnered with Marshall Space Flight Center to create that. Tell me more about it.
It will investigate a phenomenon that occurs in the South Atlantic, around Brazil, and affects communication, GPS signals. So it's important not only for Brazil, but for everybody that passes in that region.
Right, and I'm glad that you mentioned that it's not just one region, it's several regions. You know, we're not just looking at one place, but we're really helping each other out. Why is international collaboration so important?
Well, space is an open domain. We can share opportunities, we can advance in the science, we can share the risks. So that opportunity with NASA opened a new domain for us, not only with the nanosats, but with all other missions, scientific and technological missions also. We have a good future ahead. Oh, absolutely, a very bright future. You're also helping with the Artemis missions. Can you tell me how the Brazilian Space Agency is involved in those? We're involved in a lot of nanosatellites. Some of them are academic. We will have in February the first private satellite in Brazil. It's also a nanosat. We are opening in December the Alcântara spaceport for private operations. So the new space is booming in Brazil. Absolutely, it very much is booming in Brazil. Any thanks that you want to give to your teammates that have worked on these things? Well, we did that first satellite with NASA. We open opportunities for science, for technology, for business, and we hope we can do a lot of good things concerning space around the Earth and also in the Artemis. We have a mission already planning and advancing for the Artemis program. That is fantastic. A lot of great things happening in Brazil right now. Carlos, thank you so much for joining us. Our pleasure. Go to space. Absolutely, go to space. All right, now we are just about 6 minutes until liftoff of CRS-26. So let's bring back Megan here on Florida's Space Coast and Jesse live at SpaceX headquarters in Hawthorne, California, to walk us through the final moments of countdown and liftoff. Take it away.
Great, thanks, Jasmine. It's T-minus 6 minutes and 20 seconds, and the SpaceX team is working no significant issues. Weather is 80% go for T0, and the range is ready to support. Now, as far as the vehicle, at this point, RP1 fuel is completely loaded on the second stage and nearly complete on first stage. Liquid oxygen loading is underway on both stages and will complete at T-minus 2 minutes to launch. Now, we're also loading helium gas into both stages. Falcon 9 uses helium as a pressurant to backfill the propellant tanks as liquid oxygen and RP1 are consumed by the Merlin engines during ascent. Helium load began before the broadcast went live and will continue to top off until a minute and a half before launch.
And to make sure engine startup goes well, SpaceX also performs what it calls engine chill. This happened at T-minus 7 minutes, where we flowed a small amount of the super chilled LOX into the Merlin engine's turbopumps. SpaceX does this to avoid a thermal shock to the system when that full flow of super chilled liquid oxygen hits the prop system. Dragon also began its startup sequence at T-minus 35 minutes when it coordinated timing with Falcon 9. It's currently undergoing vehicle health checks, with the next big step just before liftoff when Dragon transitions to internal battery power.
Dragon is in terminal count and is on internal power.
Vehicle tanks pressing for strong back retract.
Coming up next, and we did hear that call out, the large truss structure next to Falcon 9, called the transporter erector, or what you may hear called the strongback, will begin to retract away from the rocket in preparation for liftoff. In order to do so, there are clamp arms just below the Dragon vehicle that will begin to open. Once those are fully open, and there you can see them on your screen just below Dragon, once those are fully open, then the TE can begin to retract away from the vehicle. Now, in these last few minutes, Falcon 9 is performing final health checks on its primary communications, avionics, and propulsion systems in preparation for flight. And we may hear some callouts that engines are sufficiently chilled as we get a little closer to liftoff.
Cradles come up.
There you could see at the bottom of the Dragon vehicle, the clamp arms are beginning to open up. Again, once those are fully open, the TE can begin to retract away from the vehicle.
Now, as Jesse said, the next visual cue we're going to see is that strong back beginning to recline. It will recline only a few degrees at first and then fully recline back to allow clearance at launch. Now, the next call out we'll hear is stage 1 LOX load complete. That'll happen around T-minus 30 seconds. T-minus 2 minutes and 30 seconds. As we wait for that, this is the last Dragon launch of this year, bringing about 7,700 pounds of cargo, science, and supplies to the space station. Of the 7,700 pounds of cargo going up today.
Stage 1 LOX load closed out.
There's that call out we are expecting.
Stage 1 POGO.
Our life support and medical equipment, also gym hardware and solar arrays. Dragon will be docked to the space station a little longer than usual, 45 days versus about 30, and that's to allow time to install those new solar arrays. Now, coming up in about 10 seconds, checkouts of the second stage thrust vector control actuators will be underway. This is often referred to as an engine wiggle test. It's when SpaceX moves the thrust nozzles slightly to make sure that the guidance hardware is go for flight. SpaceX does the exact same checkouts on the first stage engines, and that happens just seconds before ignition.
Now, coming up next, at the T-minus 2 minute mark, liquid oxygen loading should be completing on the second stage, and that will wrap up propellant loading for Falcon 9. Dragon is also performing its final health checks to make sure that all of its primary systems are ready for its rendezvous to the space station. Now, again, those white clouds that you see around the vehicle is the chilled gas above the liquid oxygen
Stage 2
tank
LOX load
liquid
complete.
surface. And there's that call out that stage 2 liquid oxygen
Dragon
loading
is in
is
auto
now
idle.
complete. And again, those white clouds that you see around the vehicle is the chilled gas above the liquid oxygen tank liquid surface that we vent overboard to maintain pressure in the tank as needed. When that gas comes into contact with the warmer air, it condenses into white clouds.
In about 24 seconds, Dragon transitions to internal power. Falcon 9 computers will enter startup mode, which is when the Falcon 9 flight computers will take control of the countdown, guiding the rocket through the last seconds before liftoff. And at that moment, we will hear a call out saying Falcon 9 is in startup and Dragon is in countdown. So let's wait for that.
Falcon 9 is in startup.
Dragon is in countdown.
All right, so both stages are now pressurizing for launch. We will next hear at T-minus 45 seconds the SpaceX launch director Mike Taylor verifying go for launch.
Go for launch.
All right, range remains go for launch. Weather is a go. Today will be the first flight of both the booster and Dragon spacecraft.
T-minus 30 seconds.
At launch, the International Space Station will be 260 miles in altitude, flying south of Nuremberg, Germany.
Stage 1, pressing for flight.
15 seconds.
All right, here we go.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power. And liftoff of CRS-26. Go Falcon and happy Thanksgiving ISS.
That's right, liftoff of SpaceX's Falcon 9 rocket for the 26th Cargo Resupply Mission, bringing new science experiments and solar arrays to the International Space Station.
See Falcon 9 carrying CRS-26 on its way to the International Space Station. We are throttling down the engines on the first stage, and this helps us prepare for max Q, which is maximum dynamic pressure. It's the largest structural load that the vehicle sees on ascent, and we should be passing through that period. In a few seconds here. That call out that we passed through max Q. Great views there of Falcon 9 carrying NASA's CRS-26 mission. We are coming up on a few events happening back to back. That's going to be MECO, or main engine cutoff, as the first event. That's where all 9 of the M1D engines shut down on that first stage, all 9 of those engines that you see lit up on your screen there. And that's in preparation for the next event, which is stage separation. That's where the first and second stage separate. The first stage will flip around and make its way back down to Earth and land on our drone ship named Just Read the Instructions, while the second stage ignites its Merlin MVAC engine to boost Dragon to low Earth orbit during SES-1, or second stage engine start 1. Then the last event is the boost back burn to reduce the velocity of the first stage in preparation for atmospheric re-entry. And that whole sequence takes about 30 seconds, and we are coming up on those few events happening here in a few seconds.
And MECO. Stage separation confirmed. Stage 1 boost back startup. Stage 2 ignition.
Some really cool views there. We had MECO, stage separation, the MVAC engine lighting up on your right-hand screen. We also saw the first stage kind of in the view of the second stage view there, falling back to Earth, doing a flip, and now in its boost back burn. Now that burn lasts about 30 seconds long.
Stage 1 boost back shutdown.
And there's that call out, and the boost back burn has shut down on the first stage. That is the left-hand screen. That's a view of the first stage there. On your right-hand screen, a view from the second stage looking at our MVAC engine. And you can see on your screen, on your left-hand screen, the grid fins are deploying on that first stage. Very cool views. You're watching a live webcast for the 26th Commercial Resupply Mission to the International Space Station for NASA. This is SpaceX's 54th mission for 2022 and the 5th Dragon flight to the International Space Station just this year. Now, we lifted off just about 4 minutes ago from Kennedy Space Center at Launch Complex 39A. And So far, both vehicles on nominal trajectories. Again, on your left-hand screen is a view from the first stage. On your right-hand screen, an awesome view of the second stage MVAC engine with the Earth in the background. For the first stage, in order to make its way back to our drone ship, again, just read the instructions. It has a couple more burns to execute. The first is the entry burn. That's where 3 of the Merlin engines reignite. This helps to slow the stage down as it re-enters the upper parts of the Earth's. Great call-outs there. This entry burn helps to slow the vehicle down as it re-enters the upper part of the Earth's atmosphere. Now, the second burn is the final burn for the first stage. It is called the landing burn, and this is a single engine burn that brings the vehicle's speed down rapidly in order to touch down on the drone ship. Now, you may see some bursts of gas on your left-hand screen. That is nitrogen gas burst for attitude control. And then again, you could see the grid fins. You could see 2 of the 4 grid fins on the first stage. These are hypersonic grid fins positioned near the top of the first stage. So once it's in the atmosphere, stage 1 only uses the grid fins to steer as it makes its way back down to Earth.
Stage 1
now they orient the rocket. They orient the rocket during re-entry and guide the rocket
Stage 1 entry burn
descent.
startup.
That call out, now you can see on your left-hand screen the entry burn has begun on the first stage.
Shut down.
And there you can see those engines shut down. That concludes the entry burn for the first stage. Again, next up will be the landing burn for that first stage vehicle in just about 30 seconds or so. Stage 2 is still looking good on your right-hand screen. Again, a view from the Falcon 9 second stage looking at the MVAC engine. About 20 seconds away from that landing burn
Stage 1
beginning
transonic.
on the first stage. Again, this is a single engine, the center E9 engine burn to help slow the vehicle down just enough to touch down on the drone ship.
Stage 1 landing
just
burn.
read the instructions today. And you can see that the landing burn has begun on the first stage. Let's watch as Falcon 9 touches down on just read the instructions.
Landing leg deploy.
Really awesome
Stage 1
views
landing
there. Falcon 9 has touched down, as you can see it standing tall on just read the instructions there on your screen. Now, while this Falcon 9 just completed its first flight, it marks the 153rd successful landing for an orbital class rocket. Now, next up, we do have SECO 1 on the second stage. That's where the Merlin vacuum engine will shut down. And SECO 1, or second stage engine
Stage 2
cutoff
FPS
1,
is saved.
will be coming up here in just under 20 seconds. Incredible view there with the Earth in the background.
SECO.
And there we heard the call out for SECO and watched as that MVAC engine
Nominal
shut
orbit
down.
insertion.
And great call out there. That means we have confirmation of a good orbit for the second stage, still carrying the Dragon vehicle. Now we are T plus 9 minutes into the mission. Coming up on the last major task for Stage 2, commanding separation of Dragon a couple minutes from now. Now we expect to have live video of Dragon separation from the top of the Falcon 9 second stage, which looks into the trunk of the Dragon vehicle. CRS-26 will be joining the Crew 5 vehicle currently on orbit, so we'll be back to having 2 Dragon spacecraft docked at the space station. As for cargo, today we will be delivering more than 7,700 pounds of science, research, crew supplies, and vehicle hardware to the orbital laboratory and its crew. And to date, SpaceX has sent and brought back over 250,000 pounds of crew and cargo to and from the International Space Station. The Dragon separation is just under a couple minutes away. And we should be able to get a live view of that. Some fun facts about Dragon. Dragon has 16 Draco engines, which have about 90 pounds of thrust each. But there are no Super Dracos on this vehicle, no seats, no life support systems, and that saves weight and space for faster refurbishment time, because this is a Dragon cargo vehicle versus a crew vehicle. Dragon also has fixed solar arrays on the trunk. The dark side is covered in solar arrays, and the light side is a radiator to cool the spacecraft. The Dragon can autonomously dock using its navigation sensors and centerline camera. And we are just about a minute away from Dragon separation. Again, if you're just now joining us, you are watching a live webcast for the CRS-26 mission for NASA. This is the 26th Commercial Resupply Mission to the International Space Station for NASA. This is SpaceX's 54th mission this year and 5th Dragon flight to station for 2022. And we lifted off just under 12 minutes ago from Kennedy Space Center at Launch Complex 39A. And we are just a few seconds away from Dragon separation from Falcon 9's second stage. You are looking at a live view into the trunk of the Dragon vehicle.
Dragon separation confirmed. Dragon separation
and
confirmed.
As you can see there on your screen and hearing those callouts as well, Dragon is drifting away from Falcon 9's second stage. Incredible view there. The next milestone coming up is the nose cone opening sequence. This protects the docking ring and navigation sensors. And that's going to do it for me here in Hawthorne, so I'm going to send it over to Sandra in Houston. How's it going over there, Sandra?
Hey, thanks, Jesse. Beautiful launch, as always. Great to see that. And, of course, welcome back into the International Space Station Flight Control Room here in Texas. We are standing by for confirmation of that nose cone deploy. That's the next major milestone that we are tracking today. Now, the nose cone does cover the docking hardware, which will be critical tomorrow during docking operations, but also navigation and rendezvous sensors, as well as the 4 forward bulkhead Dracos. Once open, the nose cone will stay open until the end of the mission, but will be reopened just after the deorbit burn and prior to re-entry. As we look ahead to nose cone opening, it is a process that involves opening the hard capture hooks with 6 non-nose cone hooks opening and then 6 nose cone hooks opening. And I did hear that that process has now begun. Again, we are in the process of the nose cone beginning to open. These are the same 12 hooks that will hold Dragon in place after it docks with the International Space Station tomorrow. And following the hook opening, the nose cone is deployed with motors. So we are continuing to stand by for the nose cone to open. This process can take a few minutes as all of those hooks do have to open. Once the nose cone is open, the team will have a process where each of the 4 forward bulkhead thrusters perform short impulse firings to check them out and make sure everything is performing as expected. Second set of hooks now opening. Additional steps will also take place once the nose cone is open, and that includes the spacecraft thermal control system, which will automatically be configured after the nose cone deploy sequence has started. The SpaceX team will also configure the systems on the trunk for operations. And this includes performing a health check on the solar arrays, which are wrapped around 1/2 of the trunk. And following that will be some communication reconfiguration with the team just to verify they're receiving telemetry through TDRS. That is the network of satellites that we utilize to communicate with the International Space Station. And then the final group of tasks after Dragon is on orbit, which of course it now is, we are standing by for that nose cone deployment, and opening is to check out the guidance, navigation, and control system. This will involve verifying the rendezvous plan and taking into account the initial orbital parameters, as well as looking at the targeted rendezvous burns that will be needed as Dragon approaches the International Space Station. There will also be a checkout of Dragon's star trackers and Dragon Eye. And we are hearing that all of the hooks are opening, standing by for confirmation of a good nose cone deployment. And we are beginning to get a view as the nose cone does open. Prior to this, each of the 6 hooks opened up, and now we are continuing to get these views as the nose cone opens. Once open, the nose cone, the Dragon docking hardware will be exposed. And the nose cone will remain open throughout the remainder of the flight. Continuing to get views of the nose cone opening. And we are standing by to hear a good nose cone opening. And nose cone deploy complete. Everything looking great on Dragon so far. And with Dragon's nose cone now open successfully, I do have a special guest who is dialing in today to discuss today's launch. Joining me is Jeff Arend, who is the manager of the Systems Engineering and Integration Office with the International Space Station program. So thank you so much for joining today, Jeff.
Yeah, thanks for having me, Sandra. It's good to hear your voice.
So I do have a couple of questions for you, and thank you again for taking some time on your Saturday to join us. So successful launches are always exciting, but a lot of work does go in for the crew and the people on the ground. How is the combined team feeling after today's successful launch?
Yeah, that's a great question. First, a big congratulations to the entire team, the SpaceX team for a great Falcon launch and healthy Dragon, the cargo team, the science team. It takes a lot of dedicated folks to pull off a launch. I know the ground teams are excited to get this mission off the ground, especially with the weather we've had of late. Everyone on the operations side is really excited. The flight controllers around the world, Houston and in Huntsville, Alabama, will all have their hands full with science operations, and everyone's anxious to see the science kick off as soon as docking occurs. Also, we have 2 rollout solar arrays on board, so the team will be preparing the EVA timelines, the suits, and the tools for those installs. And there are a lot of robotics with the Canadian arm associated with the mission and the arrays. So the international team on the ground is ready to go execute the mission. And the crew has been preparing for the docking, especially Josh and Nicole, who will be monitoring the approach. So I know that the crew and the teams are all very happy to see Dragon on its way to ISS.
That's great to hear, Jeff. Thank you. So my last question for you involves the fact that this is the last vehicle to launch to the International Space Station in 2022. It's been a very busy year, but the year isn't quite done yet. So any word for the teams around the world who have helped support station operations through such a milestone year?
Yeah, absolutely. But let me just kind of start with a summary of some of the things that have been going on. It has been a spectacular year. We've had 5 Russian launches and dockings. 2 of those were crewed Soyuz vehicles. 3 of those were cargo Progress vehicles, or Progress cargo vehicles, I guess is probably a better way to say it. We've had 8 U.S. launches. 3 of those were crewed Dragons. 1 was the first private astronaut mission, and then we also had Crew 4 and Crew 5. We had the test flight and docking of the Boeing Starliner vehicle that will hopefully see crew on board in the future, hopefully 2023. 2 Northrop Grumman cargo vehicles, and then, of course, SpaceX. This is the second cargo vehicle for them this year. Each time we launch one of these, we need to undock it, and for returning vehicles, the teams have to make sure that we have a safe landing or splashdown. And each of these missions brings its own challenges: new international crew members, new science, new robotics, and new operations of all kinds. And we continue to have seamless cooperation and integration of all of our international partner objectives to accomplish the mission of each of our agencies. So you asked me for words to the teams around the world that have supported this year. And well, I think I would really like to express my admiration for the teams that make it happen. those that design, build, and sustain ISS hardware, the scientists, the operations teams, those that work the spacecraft and launch vehicles, those that help us inspire students, our medical personnel, the folks that pack up the vehicle, the crew's food lab, the list goes on. And as you said, these folks are all over the world. You have my admiration and thanks, and another congratulations on a successful launch.
Thank you, Jeff. Those were some beautiful words. I'm sure the team really appreciates it. So with Cargo Dragon now safely on its way to the International Space Station, that'll do it for us here in Mission Control Houston. But do be sure to tune in for docking coverage tomorrow. We will be live on the air covering it all at 5 a.m. Central, 6 a.m. Central Time. 6 a.m. Eastern. So with that, I'll send it back over to the Kennedy Space Center in Florida and Jasmine. How's it going, Jasmine?
Thank you, Sandra. It's going well. We just witnessed another beautiful launch from Florida's Space Coast, and we are hard at work in low Earth orbit and heading for deep space. Right now, Artemis 1 is on a mission around the moon. The Space Launch System rocket lifted off from Kennedy Space Center just last week on Wednesday, November 16th. This mission will pave the way for long-term presence on the lunar surface and eventually on to Mars. The 26-day Artemis mission will end with the splashdown of the Orion capsule, which is set for December 11th, and coverage of that will begin at 11 a.m. on that day. To learn more, you can go to nasa.gov/Artemis. That's going to wrap up our launch coverage for the 26th Commercial Resupply Services mission from both NASA and SpaceX. Dragon is on its way to dock to the International Space Station tomorrow at 7:30 a.m. Eastern Time, and we'll have live coverage of that beginning at 6 a.m. right here on NASA TV and nasa.gov/live. Thank you again for joining us, and we'll leave you with a replay of today's launch. Until next time, go NASA, go SpaceX, and go CRS-26.
15 seconds.
All right, here we go.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine full power and liftoff of CRS-26. Go Falcon and happy Thanksgiving ISS.
That's right, liftoff of SpaceX's Falcon 9 rocket for the 26th Cargo Resupply Mission, bringing new science experiments and solar arrays to the International Space Station.